Assalamualaikum warahmatullahi wabarakatuh. This video is made for teaching the technique of differentiation. Okay, first, I will explain about differentiation. What is differentiation? The meaning of differentiation is the process to finding the derivative of the function. Next, there is 6 technique of differentiation, but in this video, we will put more focus on the 4 only. The 6 technique of differentiation is the sum and difference rule, the chain rule, the quotient rule, implicit differentiation, the product rule, and also linear approximation and differentiation. Okay, next, I will explain about sum and difference rule. So, there is an equation d over dx in bracket fx plus minus gx equal to d over dx f in bracket f plus minus d over dx in bracket gx equal to f prime x plus minus g prime x. So what is the meaning by the equation? So if we are given the equation and we need to use the sum and differences rule, we know that we can split the equation. And also f prime x mean is f prime x plus minus g prime x. It means that the function is already have differentiate. Next, we go to the chain rule. The chain rule is state a formula that dy over dx equal to dy over du multiplied by du over dx. So the chain rule we use to differentiate of composite function.
Alright, move to my part. I will explain about product rule in differentiation and show an example of how to solve a equation using this method. But before that, what is product rule? Product rule is a method used in differentiation when two functions are multiplied together. For example, y equal to u times v. The formula for product rule is dy over dx equal to u times dv over dx plus v times du over dx. In this formula, u represent the first function and v represent the second function. Now, let's look at example equation. Given y equal to 3x squared minus 5x plus 1 times sine cubic times 2x. We need to find dy over dx. Step 1. Define u and v. Since the equation involves multiplication of two functions, we separate them into u and v. Let u equal to 3x squared minus 5x plus 1 and v equal to sine cubic 2x. Step 2. Differentiate u. U equal to 3x squared minus 5x plus 1. Differentiate each term. Du over dx equal to 6x minus 5. Step 3. Differentiate v. V equal to sine cubic 2x. Since this is a composite function, we use the chain rule. dv over dx equal to 3 sine squared 2x multiplied by 2 cos 2x. dv over dx equal to 6 sine squared 2x cos 2x. Step 4. Apply product rule. Next, we substitute everything into the product rule formula, which is dy over dx equal to u times dv over dx plus v times du over dx. So, substitute the values. The final answer is dy over dx equal to 6 3x squared minus 5x plus 1 sine squared 2x cos 2x plus 6x minus 5 sine cubic 2x. In conclusion, product rule is used when two functions are multiplied together. We first separate the function into u and v, differentiate them, and substitute them into the product rule formula.
Next, we move to question 2b. The question is find dy dx for y equal to ln x squared over ln x cubed plus 5 using equation rule. So today we will differentiate this function using the equation rule step by step. Okay, first we need to identify numerator and denominator. Let u equal to ln x squared and v equal to ln x cubed plus 5. So y equal to ux over vx. So we differentiate the numerator first. We have u equal to ln x squared. We differentiate, we got u prime equal to 1 over x squared times 2x. After that, we need to simplify it. U prime equal to 2 over x. Next, we differentiate the denominator. We have v equal to ln x cubed plus 5. We differentiate it to v prime equal to 1 over x cubed times 3x squared plus 0. Then we simplify it, we got v prime equal to 3 over x. Okay, the next step is we need to substitute into equation rule. dy dx equal to ln x cubed plus 5 open bracket 2 per x close bracket minus 2 ln x squared open bracket 3 per x close bracket divide by ln x cubed plus 5 square. After that we need to factor out 1 over x. So We got 2 open bracket ln x cube plus 5 close bracket minus 3 ln x square divided by x open bracket ln x cube plus 5 close bracket square. So the finished answer is 2 ln x cube plus 10 minus 3 ln x square divided by x open bracket ln x cube plus 5 close bracket square. So that's the answer.
I will proceed to the next question, which is question number 3 about implicit differentiation. What is implicit differentiation? Implicit differentiation is a calculus technique used to find the derivative of a variable in a equation where the variables are intertwined and cannot be easily isolated. Okay, so this is the example question for implicit differentiation. Find dy over dx for ln 2x plus y minus sine square of 3x equal to exponent power of 5y plus 3xy. So first, you should to differentiate 3xy using product rule. So u for u equal to 3x, while v equal to y. So u prime equal to 3, v prime equal to dy over dx. So why dy over dx? Because when you differentiate y, you should to put dy over dx. So for the step 1 is you should do differentiate ln 2x plus y, which is you can get 1 over 2x plus y multiplied by 2 plus dy over dx. So for the next is negative sine square of 3x, differentiate it, you can get 2 sine 3x multiplied by cos 3x multiplied by 3. So equal to exponent power 5y plus 3, you can get it, when you differentiate it, you can get exponent 5y plus 3 multiplied by 5 dy over dx. So plus 3xy, when you differentiate it using product rule, you can get the answer is 3y multiplied by dy at dx plus y multiplied by 3. So for the step 2, allocate the term with dy over dx on one side of the equation. So I will put all the equation of dy over dx in the left side. So you factor out dy over dx. So for the last step is if you can solve for dy dx, and you can get the final answer, which is 3y minus 2 over 2x plus y plus 6 sine 3x cos 3x over 1 over 2x plus y minus 5 exponent power 5y plus 3 minus 3x.
Okay, so we go to the question number 4. Question number 4 is about linear approximation method. Linear approximation is a way to estimate the value of a function near a point using a straight line. So we go to the question, and step number 1 for the question, write a given expression of the question into function to make different situation easier. And step number 2, let the function be fx. Then we differentiate to be f prime x. We put f prime x equal to 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. And then we go to the step 3. Step 3, let the x equal to 80.99 and x not equal to 81, because 81 is close to 80.99. Yes, and which is way easier to find the delta x. Delta x equal to x minus x naught, and we get the answer minus 0.01. And step number 4, substitute the x naught into the function, and then we got the answer is 2.77x. Next, substitute to the derivative of function to find the f prime x, and we got the answer is 0.016310. And then for the last step, which is step number 5, we substitute the number we got, the answer we got, to the formula of linear approximation, which is fx approximatively equal to fx naught plus f prime x naught times delta x. So we substitute the number to the formula, and we get the fx 80.99 approximately equal 2.778 plus 0.016310 times negative 0.01, and equal to 2.778 plus minus 0.0001631, and then for the answer is 2.77x.
So I will continue with the conclusion. Derivatives are constantly used in everyday life to help measure how much something is changing. They are used by the government in population census, various types of science, and even in economics. Knowing how to use derivatives, when to use them, and how to apply them in everyday life can be crucial part of any profession. So learning early is always a good thing. So in this video, we have learned how to differentiate function to find their derivative. I hope this video helped the student out there. That's all from group 3. Thank you for watching.